All right, my friends, let's first make sure we're clear on what it is that we're looking for. So we're looking for the distance from the boat to the shoreline. So that would be represented, in any number of places since the boat is traveling parallel to the shoreline. So that would be represented here from where the boat was at the first sighting of the lighthouse, and then that could also be represented, here anyway. So it's nice to know, I guess, that you've got some flexibility in where you see that distance. So that's the distance we're solving for. So to get there, we'll do a little bit of angle chasing first. So for example, if this angle right here is 70, then I hope it makes sense, and then this one would be 20 degrees. Let's see, here we have a 90-degree angle, and then if you add 90 and 63, then you would get, what would that be, 153. So just to be clear, I'm kind of focusing in on this oblique triangle here for now. The idea is that if I could find that longest side of that oblique triangle, then I would be able to then use maybe just a little right triangle trigonometry to solve for that distance, as I have it labeled there with D. So anyway, so this angle all the way from here to here is equal to 153 degrees. And then that would leave not a lot for this angle down here. And so let's see, 153 plus 20 is 173. So that would leave a little 7 degrees for that angle right there. Okay, let's see now. Okay, and then we have opposite 7 degrees. We have 2.5 miles. So boom, that's your complete ratio right there. So sine of 7 degrees would go over 2.5 miles. And then since I'm trying to find the longest side in that oblique triangle, I would set up a partial ratio here, partially complete ratio, of sine of 153 degrees over, and I guess I'll just call that distance x. There we go. All right, a little cross multiply and divide. There we go, and then calculate that. 2.5 times sine of 153, subtotal it, and then divide by sine of 7. Okay, and it looks like that distance would be approximately 9.313. 3. Okay, miles, there you go. Okay, all right, but that's not the distance we're trying to find. We're actually trying to find that D value over there. So now I'm going to transition to looking at this right triangle over here. There we go. And it's you could use law of sines, but why would you? It's a right triangle. So from here, let's see. I know this 70-degree angle, and I now know what x is, and I want this distance right here. So compared to the 70-degree angle, I want the hypotenuse of this right triangle, and I have the adjacent angle. So that sounds like cosine to me. So cosine of 70 degrees would equal adjacent, which would be D, over hypotenuse, which I've found to be 9.313, etc. I still have that value sitting on my calculator with all the extra decimal-y goodness. There you go. So one more move, and I've got D solved for. I'm just going to multiply both sides by 9.313. There we go. All right, and so I have it actually is 9.31305788883, and then probably more stuff after that. But I still have it sitting on my calculator, so I'm going to use that instead of typing it in with the rounded version. Okay, and then I end up with that distance being approximately 3.185. There we go. All right, my friends, so I could say miles there. Remember, story problems deserve story answers. So a little sentence to sum it up. We would just say the distance from the boat to the shoreline is, remember the word approximately to show that you did round it just a little bit, 3.185 miles. There we go. All right, my friends, that's the last example for this lesson. I hope the problem set goes well, and I hope you're willing to ask questions in the moments that it doesn't. Take care, everybody.